Okay, so you've now got all of the bits of data that you need to generate your forecast. We have our targets and we have our NOAA data, both our historical observations and our future weather forecast. To generate a forecast of water temperature, we're going to use just a really simple linear model between historical air temperature and water temperature to train our model and then run it forward with our future water temperature for weather forecast to generate our water temperature forecasts. To start, I'm going to join our historical data with our targets just to help with visualizing the data and making it a little bit straightforward. This is not necessary, but I find it makes it a little bit easier. And we can have a look at what our data look like. So we have both our water temperature data, our targets, and our stage 3 air temperature data from NOAA in the same data frame, and we can use these to fit our model. For the linear model, we're just going to use the base RLM function, but there are a number of methods in the Fable package, both linear and non-linear model fitting, that might be interesting if you're interested in these empirical approaches. The Fable package also includes a number of other empirical approaches for developing your forecasting knowledge and tools that I would recommend. The next step is to just get some bits and pieces together to improve our, make the forecast generation a little easier. The first is to generate an empty data frame that we can fill with our results from our forecast. We're going to make a forecast that goes 30 days out into the future. So our horizon is 30 days. And we're going to use that to generate a sequence of dates that are going to require forecasts. So if we look at the forecast dates object, you can see we have a number of dates going out into the future. Each of these will require a forecast. Next, we're going to fit our model. So we're going to fit a model between water temperature and air temperature. You can see this model fit has two parameters, as you would expect from a linear model. It has an intercept and it has a gradient. The first coefficient is the intercept and the second is that gradient. I'm just going to assign these to an object that we can query. To actually generate our forecast, we're going to use a for loop that's going to loop through each of the dates that we need to make forecasts of. So for every time step from 1 to the end of the forecast dates, we're going to filter the future weather based on the date that we're trying to forecast. We're then going to use the structure of the linear model to generate the forecast based on those future air temperature drivers. And then this last step is just to put it into a data frame to make it easy to tell which date was being forecasted, etc. And then these get every time time steps gets looped over, we will combine these into the data frame. And so just for demonstrating, I'm just going to show you what happens with that first time step. So we're going to filter the future weather based on the first date time. And if you look into that temp drive data frame, you can see here that it's only forecasts for that first date. So our first date in here is the 25th of May, sorry. And you can see that there are 31 ensemble members for air temperature on that date. We're then going to use our model to generate water temperature predictions based on those air temperature ensemble members, combine it into a data frame, and that's going to look something like this. We have the date time. So for this first time step, it's just that one date. We have our predictions based on our linear model and each of the ensemble members that's associated with those predictions. And the final step is just to combine that with our existing data frame. Now, for the first time step, we don't have an existing data frame. So you'll see here our forecast DF only has 31 rows, but when we run this for the full forecast, you'll see that our forecast DF now has 30 days of predictions. Each of our days has 31 possible forecasts of water temperature. And I'm just going to plot these just to show you what it looks like. This looks like very complicated plotting, but I just wanted to demonstrate like a couple of different things that we've done so far. So this plot here shows both our past observations, our target data that have been collected, and those come right up until the day our forecast was generated. We have almost real-time data for Falling Creek Reservoir water temperatures, and so we can use all of those targets to fit our model. Then we have these multiple lines that show multiple future simulations of water temperature going out into the future. And you can see, as with our NOAA forecast, we see an increase in uncertainty as we go out further into the future. And then we have our reference date time, which is the date that the forecast was generated. And that corresponds to the day that I'm making this video. And that reference date time kind of splits between our past observations and our future forecasts. Final step before we submit the forecast to the challenge is to make sure that our forecast is in that standardized format. If you watch the previous videos, you'll have seen these column names that we need, but they're here for your reference if you need them. So we need to add a couple in that we don't have yet. So our forecast data frame is not yet complete. We need to add a model ID. The model ID that I'm going to use for this example is example ID. And just to note that if you're kind of learning how to make these submissions, you're running through the tutorial, you're kind of playing around with different methods that you might want to use, I would encourage you to include example in any submission that you make. This will mean that it's still scored and you can see how the forecast performed, but it's not going to be included in any synthesis or anything like that. Once you're ready and you feel like you want to start making more submissions, maybe in an automated way, make sure your model ID doesn't include the word example and that it describes kind of roughly your methodology or the approach that you're taking to your forecast. We need to add in those family and parameter columns that describe the representation of uncertainty. So for this forecast, we use the ensemble members from NOAA to include driver uncertainty, and therefore we have an ensemble forecast. We need to include the duration. So this is a daily forecast. The depth at which we're forecasting for this particular variable was 1.6 meters, and then the project ID. So we can go ahead and run those lines of code. And we now have we should have a forecast that is ready to be submitted to the challenge. To help with the submission steps, the forecast challenge organizers have developed the Vera Forecast Helpers package, which hopefully you've downloaded and installed. These includes 2 additional functions above the NOAA ones that we've already used. We're going to use the submit function and the forecast output validator, which I find really helpful just to check that the files that we're generating are going to be accepted by the challenge before you submit them. It's going to be really helpful when you're like developing your workflows and just making sure everything's correct. We're going to save the file. This is going to generate a forecast directory in here that's going to include the CSV of the forecast that I just generated. We'll use the forecast output validator first. You can run this code, make sure that the forecast file includes the full file path for the file that you just wrote. And you can see here, it's checked like which columns you have, whether they're in the right format, whether the variable that you said you're forecasting exists, that it's going to score correctly. And you can see here that we have a nice, lots of green ticks and true for our is it valid. So we can go ahead and submit. We can use the submit function from the Vera Forecast Helpers. And again, you want to make sure that the forecast file there includes the full file path for your saved file. It's going to do those checks again. And it just gives us a reminder here that we're using an example. If we are going to analyze like a lot of forecasts, and they're going to be including like a synthesis of different models, for example. You want to make sure that your model ID doesn't include example, but you will need to register. And there's a link here to register your model once you're ready for this. So we submitted a forecast to the challenge. That's great. The next step is, I guess, to think about whether that's a good forecast. Are there additional methods that might improve our forecast? Are there different types of covariates that might improve our forecast? Potentially, if we look at the linear model, so this is going to plot air temperature and water against water temperature. You can see here, linear model is not bad. It goes up when the other one goes up. But maybe there's a slightly different structure that might be needed in here. We also have quite a lot of additional uncertainty that model is not capturing. And maybe could we include the residuals from this model in as an additional source of uncertainty? If you're particularly interested in adding other sources of uncertainty, I would recommend the Macrosystems Eddy Module 6. There's R code available via GitHub. That's really great about introducing the different uncertainty sources and how to integrate them into your model. You might also want to try adding forecasting a different variable. As I showed you in the previous video, there are a lot of different variables available within the project, maybe oxygen, maybe some biological variables, or maybe you want to add another covariate. Have a go at adding different variable names into those NOAA stage 2 and stage 3 before you're collecting in order to add additional covariates. Once you've come up with an amazing forecasting model, make sure you register your participation, otherwise you won't be able to submit those. And you can also find more instructions on the Vera website. So we've gone through all the stages of a simple forecast workflow, and I've introduced you to some of those building blocks to help you develop your own forecasting workflow. Maybe that's how to get the NOAA data, how to get the targets, or the submission steps. What you want to do next is have a go at developing a new forecast. Maybe, as I said, that's for a new variable, using a different model structure, or adding different sources of uncertainty. The next video that I'm going to show is how to automate your forecast. So you've got your great new forecasting model and you want to go ahead and automate those. And that's going to be in the next video.